Hi everyone! Today we're going to explore into the fascinating world of trigonometry. Ever wondered how engineers build towering skyscrapers or launch rockets into this place with such precision? The answer lies in the mathematical concept of trigonometry. But let's face it, sometimes traditional textbook can make learning it a bit tedious. That's why we created this unique comic strip, Euclidean ESCAPADES, to demonstrate how trigonometry is not just about equations and formulas, but a powerful tool in real-world application. Through this comic book, you will see how trigonometry is being utilized in various implementations. Let's dive right in.
Did you know that Pythagoras' theorem was discovered by a Greek mathematician and philosopher, which is this person, Pythagoras of Samos? And Pythagoras' theorem states that the square of the length of the hypotenuse is equal to the sum of the square of the other two sides, which can be expressed as a power of 2 plus b power of 2 equal to c power of 2, which is the hypotenuse. And this Pythagoras' theorem is very applicable to our daily life, such as in physics subject, engineering, and also architecture. Bye.
Moving on to the next solution for comic Sky is the Limit. The problem is we need to find the most suitable angle to launch the rocket, so the rocket will reach an altitude of 70 meter in range of 75 meter. The solution is we need to apply the concept that has been explained before to solve this problem. Next, we use formula tan equal to altitude over range. Then we insert the value of altitude and range with 70 meter and 75 meter. So the most suitable angle to launch the rocket is 43 degrees.
Hi, so today I'm going to explain about the concept used in comic Husky string, which is double angle formula, where it uses basic trigonometry to derive the formula sin 2x equal to 2 times sin x cos x. The double angle formula used to express the trigonometric ratios of double angles in terms of trigonometric ratios of single angle. As the double angle formula are a special case, we'll use the summation formula of trigonometric function, but in some cases, we use Pythagorean identity. In this case, in order to derive the double angle formula of sine, we use the summation formula of sine.
For the final solution, this comic strip demonstrates how we being applied the building concept from trigonometry. So here is the solution for the how we found the double angle. So here we have gain timber value, and this is a perpendicular gain timber value. So we just substitute the value of 2, which is sin theta and cos theta, in the formula that was given before. So after we plug in the value of vertical stress and the horizontal stress, so we're going to get sin theta 0.87. So we must find the theta. So the theta will be equal 30.23 degree. So that's the degree between the horizontal force and the vertical stress. So how we going to get the opposite value? So just time 2. So we're going to get around 60 something. That's why we call it double angle. You all might be wondering why we must need to find the double angle. So we can find the resultant stress. So why we must find the resultant stress? We can find from the resultant stress, we can find here the mass capacity that the bridge can handle, which is here around 8 kilonewton, 8,000 kilonewton. Before we end our solution, we must also apply the safety factor of which is n equal to 2, which means we design the maximum force to be half of the rated capacity. This will decrease the chance for the bridge to fail. So which means before we get the 8,000 kilonewton, so we divide it by 2, so we're going to get around 4,000 kilonewton. Bye.
Have you ever heard about trigonometric function? There are 6 basic of trigonometric function, which are sine, cos, tan, cosecant, secant, and cotangent. So as you can see here, so sine is equal to opposite over hypotenuse, cos is equal to adjacent over hypotenuse, and tan is equal to opposite over adjacent. So if you are given the hypotenuse and the theta, you can use the sine formula to find the opposite, and you can use the cos formula to find the adjacent.
Moving to the solution, first we can assume that the building's length is 55.27 meter and the angle is 5.31 degree. Then using the trigonometric function, we can calculate how long the building has been deviated from its initial position. Then we insert the data sin 5.31 equal to x per 56.26 meter. Then we can get the x, which is 5.21 meter.
So whether you are a math enthusiast or someone simply curious, about learning how the world is being built around you, Euclidean ESCAPADES is the perfect way to explore the exciting world of trigonometry in a fun and engaging way. Physics are derived and maths are equally the derivative of physical phenomena. So buckle up and get ready to discover this concept through the lens of our comic strip. Group 7 Year 7, signing out.